This video is all about syllabus statement 3.4.2, which is describing the formation of ionic bonds between metals and non-metals. This video will be focusing predominantly on elements in group 1 and group 7 today, so enjoy. Thank you.
Before we get started, check out this awesome chemistry cartoon. Hopefully by the end of this video, you'll be able to explain it in a little bit more detail. One of the key facts for this syllabus point is that ionic bonds are always formed from metals and non-metals. Don't forget that non-metals live on the right-hand side of your periodic table and the metals live on the left.
So let's look at two elements to look at how this works in more detail. So what I've got here is I've got sodium, which is from group 1, and chlorine, which is from group 7. You can see this because sodium has 1 electron in its outer shell and chlorine has 7 electrons in its outer shell. So this tells you the group number. So in terms of how these guys bond together and how they can form an ionic bond and what holds them together, that's what we're going to look at now. So neither of these right now have a full outer shell, and both of them want that full outer shell. What you should be able to see is that if this 1 electron moves over to the chlorine here, then what you will end up with is you'll end up with a full outer shell on that chlorine, and you'll end up with a full outer shell on the sodium. So what happens here is that this electron here in the outermost energy shell of the sodium moves and is transferred to the outermost energy level of the chlorine atom, just so that it can have that full outer shell that it's really aiming for. If we look at what this looks like afterwards, what we've got now is we've got this sodium here, which has now got 8 in its outer shell here, and this chlorine on the other side, which has also got 8 in its outer shell. So everybody's happy, everything is good. The thing that is weird is, why do they now stick together? What makes that an ionic bond? What holds them together? Now, what you need to do is you need to remember the fact that this has now lost an electron. Electrons are negatively charged, remember? So if it's lost an electron, that means that overall this has a positive charge. The number of protons outweigh the number of electrons. The chlorine has gained an electron. It came from the sodium. I've drawn it in a different way just to show that it came from the sodium. And if I draw my square brackets around this, it's gained another negative, so it is negatively charged. Because these have different charges, it is something called electrostatic attraction that holds these two things together, because of these two charges attracting each other.
To summarize for you, electrostatic attraction is the force of attraction between two oppositely charged ions. Let's check out the cartoon we looked at the beginning. Do you get it now? If you do, post in the comments.